Assalamualaikum. This is my second lecture. We have just discussed what wave and wave motion is. Now we will study the properties of the wave motion. Whenever we talk about properties of the wave motion, we come across some terms, and those are what is wavelength, what is frequency of the wave, what is period, what is phase, what crest and troughs actually are, and what is the speed of the wave speed. So let's start what actually wavelength is. The simple definition, which is written everywhere, is what is wavelength? It's a distance between two consecutive crests or the troughs. Okay. In some books, it's written as it's a distance between the 2 points that are in the same phase. Phase. The distance between the 2 points that are in the same phase. So let's discuss what actually phase is. But before that, let's talk about a vibratory motion first. Wave to burning, let's discuss this vibratory motion with the help of a pendulum. What I want to explain, तो पहले उसको समझने फिर आपको समझ आएगा. Whenever we draw a wave, we draw a rest position first. The same way whenever we talk about pendulum, this is its rest position. When we drag it to a certain height, this is its extreme position. So whenever pendulum swings or it vibrates, it has 2 extreme positions and 1 rest position. Let's talk about the velocity of that vibration. Whenever pendulum vibrates, when it is approaching its extreme position, its velocity is becoming weak, and it's 0. And from there, it starts moving and it starts accelerating. And when it's passing through this mean position or rest position, velocity is maximum. And when it reaches the extreme position, velocity becomes 0. That means velocity is 0 at extreme and velocity is maximum at mean rest position. So velocity is maximum at rest and velocities are minimum or 0 at extreme positions. And if you talk about accelerations, what's the reverse? So accelerations are maximum at extreme and acceleration is 0 at rest position. So let's talk about that velocity now. Velocity, extreme position पे 0, mean position पे maximum, right? इसी को अगर मैं wave में draw करूँ, mean and extreme position. So how am I going to draw this in a wave? Let's take an example. For example, this is a rigid support. This is the rest position of your wave. And wave is produced like this, and so on. Right? What this position is, if I mark it as O, this O is actually the rest position. Right? Or this is the mean position. Whenever particle vibrates, they move up and down. If this is the mean position or the rest position, these are the 2 extreme positions, right? Where velocity is maximum? Velocity is maximum at rest position. So how I'm going to show that velocity? That velocity is shown with the help of an arrow. If it's greater, the height of an arrow मैं थोड़ी सी increase कर दूँगा. When that particle shifted to this point, velocity decrease a bit. So length of arrow थोड़ा सा shrink कर देते हैं. When the particle moves to this point, velocity decreases more. And at this point, it's 0 because it comes to rest. And when they come to mean position again, rest position again, at the same distance, they have the same velocities, but direction changes like this. Hope you're getting it. Right? So what I've done, when particle vibrates at mean position or rest position, the velocity is maximum, and when it is moving towards an extreme position, the velocity is getting decreased, and at extreme it's 0. When it again moving towards the rest position, at the same point, at the same level, velocities are same, but the direction changes. And same if it moves downwards, here, velocity will decrease. Here, it will decrease more, and at this point it's 0. And same, if I draw it like this. Now, what I want to explain actually, I want to explain the term phase. Let's complete the diagram. If it's moving again towards that. Okay. This is how I'm drawing. Okay. Now what is phase? Okay, phase, the 2 points from the rest position having the same direction of displacement, having the same speed, are said to be in the same phase. If I mark this point, of course, this is the rest position. This point, this is the rest position. Velocities, they are same, but the directions are not same. These 2 points are not in the same phase. But if I say this point is going upright, and this point going upright, position same, displacements, velocities, that means these 2 points are in the same phase. This point is going up, this point going down. So they have same velocities, same displacement from the rest position, but the directions are opposite. So these 2 points are not said to be in the same phase. What about these two? Yes, these 2 points are in the same phase. The 2 points that are in the same phase, resemble these two, or we can mark them these two, or this point and this point. All these points are in the same phase. The distance between the 2 points that are in the same phase is the wavelength. And what actually phase is? The 2 points from the rest position having the same direction, velocity and displacement, they are said to be in the same phase. And the 2 points that they are in the same phase, they constitute a wavelength. What we call this point, it has no particular name. What we call this point, it has no particular name. But what that point is called, this one, yes, we have named it as crest. This point, it's crest. So in simple terms, the 2 crests means these are the 2 points that are in the same phase. We can say the distance between the 2 consecutive crests is called what? A wavelength. So the simple definition for wavelength is the distance between 2 consecutive crests or the troughs. Why? The distance between 2 consecutive crests and 2 consecutive troughs is called a wavelength. It's denoted by a Greek symbol lambda. Why distance between 2 consecutive crests or the troughs is called the wavelength? Because 2 crests are in the same phase. What same phase means? The 2 points on the waves which are at the same distance from the rest position, same direction and having the same speed. So the 2 points in the same phase constitute a wavelength. It's denoted by lambda. So can you mark another wavelength? Yes, we can mark another wavelength. Distance from this point to that point. These are the 2 points that are in the same phase. This is also called what? A wavelength. A wavelength doesn't mean कि मैं इस तरीके से एक upper portion draw करूँ एक lower portion. Wave means the distance between any 2 points that are in the same phase. And same phase में कौन से points होते हैं? वो points होते हैं same phase में जो कि rest position से same displacement, same direction or same velocity. Hope you know now you have got an idea what actually the wavelength is. Wavelength is symbolically denoted by a Greek symbol lambda. And how can you define wavelength? It's a distance between 2 consecutive crests or the troughs of the waves, or it's the distance between the 2 points of the waves that are in the same phase. The second point, the second property is what actually phase is. Now you can define phase. What is phase? Phase actually the 2 points of the waves which are having the same energy, the same velocity, the same displacement from the rest position, and they are in the same direction as well. They are said to be the same wave. But what we are discussing at the moment, these are the properties of wave motion. Okay, so this is what actually wavelength and phase is. The next important term, it's an amplitude. What is an amplitude? It's a maximum displacement of a vibrating body from its rest position to any of its extreme positions. So whenever vibration takes place, pendulum vibration, it vibrates like this. This is its rest position and these are the two extreme positions. So when wave is formed, particle usually vibrates. This is its rest position and these are the two extreme positions. What actually amplitude is, if I draw it as an example of a pendulum, so when pendulum is dragged to certain height, for example like this is the pendulum. What actually pendulum is? It's a system which comprises of a bob, hook and an extensible thread. This is the pendulum. This is its mean position or rest. And these are the two extreme positions. So how can you define an amplitude? It's a maximum displacement from the rest to either of its extreme positions. So how many extreme positions we have? Two. So from rest to extreme positions, this is called what? An amplitude. This is an amplitude. From rest position to either of the extremes. So when we talk about wave, so this is the wave, this is the rest position, the maximum displacement from mean to either of its extreme positions is called what? An amplitude. This is an amplitude. So these are the amplitudes of the wave. Two extreme positions and one rest position. So this was the third most important property of the wave motion. The fourth one, it's called a frequency. What is frequency? Frequency may be defined as the number of waves produced in 1 second. एक सेकंड में जितनी waves produce होंगी वो उसकी wave frequency कहलाती है. Frequency is symbolically usually denoted with small f, or we can denote it with the Greek symbol nu, N-E-U. So sometimes we write it as small f, sometimes we write it as nu. So what frequency is? It's the number of waves produced in 1 second. क्या मतलब है? For example, ये मैं 1 सेकंड के दो स्पैन्स बना रहा हूं. इन दोनों स्पैन्स का जो टाइम है वो है 1 सेकंड. ये भी टाइम स्पैन कितना है? 1 सेकंड. Now what you will observe, यहां पे मैंने वेव बनाई like this, और यहां वेव बनाई like this. So how many number of waves you are getting produced in 1 second of time? 1, 2, and 3. So that means the frequency of the wave is 3 hertz or 3 waves per second. And what is happening here? In 1 second time span, you are getting only one wave. What would be your frequency? It's 1 hertz or 1 wave per second. What is frequency? It's a number of waves produced in 1 second of time span, like this. You will observe one more thing. अगर मेरे पास frequency high है, frequency, so wavelength short हो जाती है. And if I have low frequency, so wavelength long हो जाती है. So low frequency, long wavelengths. High frequency, short wavelengths. So this was frequency. Next is, what is period? Period of the wave. But sometimes we call it a time period. And it's denoted with a capital T. What is a period? So frequency was number of waves produced in 1 second of a time. And what is period? Can anyone sitting at the back? Okay, so what actually period is? The frequency and number of waves produced in 1 second. And what actually period is? time required to produce one wave. एक wave को produce करने में जितना time चाहिए वो उसका period कहलाता है. Period, or we call it time period. So if we repeat the definitions, what is wavelength? It's the distance between the two consecutive crests of the troughs of the waves, or it's a distance between the 2 points that are in the same phase. What phases? Phases are the points on the wave having the same velocity, having the same displacement from the rest position, and most importantly, they should be in the same direction. Next, what is an amplitude? Amplitude of the wave is, it's a maximum displacement from the rest position to either of the extreme positions. So we have two extreme positions. So in a wave, in a single wave, we will be having two amplitudes. Next is frequency. Frequency symbolically denoted by the small f or a Greek symbol nu. What frequency? It's the number of waves produced in 1 second. These two examples elaborates what actually frequency is and how it is calculated. So this diagram shows the frequency of the wave is 3 Hz. That means 3 waves are produced in 1 second of a time. And this diagram says 1 wave is produced in 1 second of a time. And when we have high frequency, so the wavelength is short. And when we have low frequency, the wavelength is long. Last but not the least, it's periods. So what period is? It's the time required to produce one wave. The time required to produce one wave is called period of a wave. The next important definition that we will be discussing in the next lecture is what wave front is. To study wave front, what actually wave fronts are. Wave front ko padhne ke liye you should be aware of the concept of what is a phase. And to get the concept of phase, you should be aware of the diagram. What these arrows are actually drawn for, it's very important. So arrows किस चीज को show कर रहे हैं? What about their heights? Very important. If you have a concept of a phase, the next topic that we will be studying is a wave front. So that is easily understandable. Inshallah, the third topic that we'll be studying, that will be the wave front, and then a ripple tank, and then your past paper के questions. That means कि past paper तक पहुंचने के लिए, if you don't have a concept clear, you can't go with those questions. So your approach कि आपका concept clear होना चाहिए. So I am explaining wave with the help of this pendulum as well. तो आपको समझने में थोड़ी सी आसानी हो जाएगी. Hope you have got the concept. So next lecture के लिए wait कीजिए. That will be the wave front, how ripple tank works, and reflection and refractions of those waves, or shallow or deep water के अंदर how they behaves along with the wave equation. So stay tuned. So next lecture will wait कीजिए.